Good afternoon, Livi and Mohit. Thank you for taking the time to attend. Good afternoon, Livi and Mohit. Thank you for taking the time to attend this presentation. Yeah, our team name is 514A Group 2, and our team member are Jia Zhenshen, Hong Dai Lo, Le Yanho, and Xin Yi Zhang. Yeah, we were explaining from these 5 points. Yeah, let's begin. The date description. Yeah, the project is based on airline customers satisfaction survey date. Our goal is to predict whether a customer is satisfied, neutral, or dissatisfied. Uh, why does this matter for the business? Satisfactions impacts reports, repeat purchase, brand mix, and the market share. Knowing what drives satisfaction helps improve customer experience. The sport help customer early. Let's take action and keep them from leaving. Yeah, this project is one of the business analysis takes supported by our analysis team. We talk over initial model code left by our former colleague and optimize and important based on is enhance the model's effectiveness and business interpretation ability. Yep. So why we are improving it? First, logistic regression. The original version did use any regularization, which makes it prone to overfit. It also encodes all feature without any selection, so there may be noise, but we don't turn the hamper parameters, so the predictive performance was quite limited. Yeah, next, the distinction tree is easy to understand and visualize, but it's turned to overfit the training data, especially since we don't have planning. Planning is that really affects its ability to generate to new data. And for the neural network, the powerful for capturing non-line patterns, but it's also very complex. There are a lot of the parameters and it's quite sensitive to training. So results can vary a lot of it. It's not well turned. Yeah. So let's introduce logistic regression. Yeah. Logistic regression model is easy to interpret. We can see exactly how each level affects a customer's satisfaction, which helps us a clear suggestion to the business. It's also fast and reliable, especially for maids size this size. We can train it quickly without much hassle. Plus, it's flexible. We can aid the regularization and advise overfitting or use cross validation to boost the performance. Best of all, it gives us a portability of outputs, so we can adjust the thresholds depending on business goals. Yeah, regularization is super helpful, especially when we have a lot of feature and highly quality data. The L1 regularization helped by pushing some correlation coefficient to 0. So it's like the automatic feature selection. L2 regularization smooths out the whites, which makes the model more stable when features are related. With electronet, we can make the two using the L1 ritual, giving us the best of the both worlds, sparsity and stability. It's not just efficient, it's also makes its model more reliable on new dates. To get the best results, we use the cross validation and hyper parameters turning to find the ideal combination of regularization strengths and L1 ritual based on the ROC AUC score. Yeah, the initial model performs well in identifying positive cross sample, achieving a recall of the 77%, indicating strong sensitivity to key cases. Although recall slightly dropped, the optimized model showed joint genes precision and overall robustness. It requires critical. The original model may be preferred. It controlling false positive and achieving stability is key. Its optimized model is more suitable.
The second method we employed is the decision tree model. Decision tree is a simple and easy to understand model that works well for classification tasks. In this project, I improved the basic decision tree step by step to get better results. The first step was hyperparameter tuning. I used randomized search to try different combinations of settings like tree depth and splitting rules. This helped the model find the best setup automatically and improved its accuracy, while also reducing the risk of overfitting. The second step was resplitting the dataset. Instead of just using a training set and a test set, I divided the data into three parts: training, validation, and test sets. In this way, I could adjust the model using the validation set without touching the test set until the very end. It gives a more honest evaluation of how the model performs on new data and helps avoid overfitting. The third step was adding pruning and feature selection. Pruning makes the decision tree smaller by cutting off parts that don't help much, which helps the model generalize better. Feature selection keeps only the most useful features, removing less important ones that might add noise. And these are the training results of the basic decision tree and each optimization step. After adding hyperparameter, tuning, and resplitting the data, the model performed much better. This is likely because randomized search helped find the best settings and use a separate validation set made the tuning more reliable. Together, these two steps gave the model a better balance between learning and generalization.
This part I will walk you through how I built and enhanced a neural network model to predict airline customer satisfaction. This is a binary classification task where we aim to predict whether a passenger is satisfied or neutral dissatisfied. The base model came from a former colleague, but it was quite simple and prone to overfitting, so I made several improvements to make the model more stable and generalizable, which I explain in the next slide. I redesigned the network with 3 hidden layers, 128, 64, and 32 neurons each followed by dropout to control overfitting. I also added L2 regularization, used the add-on optimizer with tuned learning rate, and included early stopping to monitor validation loss. I put the key code on the PPT. These improvements helped the control model complexity and made training more robust. The improvement model achieved 87.5% accuracy on the test set, which is significantly better than the original baseline. The confusion metric shows that both classes were predicted accurately. Previous precision was high, but recall was low for dissatisfied customers. After tuning, the performance became more balanced. I put the key code on the PPT. This helped stop trending before overfitting kicked in. This model offers concrete and actionable business value. Instead of waiting for customer complaints, the airline can now proactively identify dissatisfied passengers based on predicted probabilities. For instance, a predicted satisfaction probability below 0.3 could trigger automated alerts to frontline staff, enabling real-time intervention such as offering personalized apologies or upgrade before arrival. Moreover, we observed that dissatisfaction is often linked with economy class and low service quality ratings. This allows the airline to prioritize service improvements for specific flight classes or routes. In day-to-day operations, this model could integrate with CRM systems to flag high-risk customers, improve net promoter scores, and reduce churn. Overall, it's not just a prediction tool, it's a strategic asset that supports customer retention and revenue protection.
I'm here to present our passenger satisfaction prediction project and its business impact. We evaluated decision tree, random forest, XGBoost, and soft voting ensemble. The ensemble achieved 0.8 accuracy and 0.8 marker average F1. For dissatisfied passengers, recorded 0.84 position and 0.81 recall, maximizing early identification of high-risk travelers. By outputting features importance, online checking, in-flight entertainment, and seat comfort, our module serves a real-time decision-making tool. Management can dynamically allocate crew, prioritize maintenance on entertainment systems, and focus investments on the service elements, yielding the highest satisfaction ROI. Flight implementations on key routes improved online check-in score by 1.3 points, lifting passenger satisfaction by 9.5 points, and reducing complaint rates by 15%. Upgrading in-flight entertainment increased paid service revenue by 7%, and ergonomic seat modifications cut seat-related complaints by 10%, translating into a Net Promoter Score uplifting of 5 points. Real-time feedback is enabled through short in-flight questionnaire and self-check service in triggers. With 84% precision in detecting dissatisfaction, crew receives instant alerts to intervene, offering extra refreshments or coupons. While post-flight outreach re-engaged 11,844 flight passengers, boosting completion rates and retention. Dynamic resource optimization reduced boarding queue time by 15% and entertainment system failure rate by 20%. Automated maintenance scheduling and staffing adjustments have delivered 5 to 7% in annual operating cost savings. We also launched ultra-fast boarding, crystal clear entertainment, and ergonomic luxury seats as unique selling points, plus the super economy class sale. Targeted marketing campaigns leverage module probabilities, upselling seat upgrades yielding 20,444 retention. Retention offers are generated 236,800 in potential lifetime value, and repurchase increase added $34,062, with total incremental revenue of $289,000 per route, nearly 2.9 million across 10 routes, and a 2% repurchase rate lift. The ROI is compelling. This data-driven closed-loop predict, diagnose, intervene, evaluate solution drives substantial revenue growth, cost savings, and sustained competitive advantage for the airline.